Hi, everyone. Thank you for tuning in for the talk on mitigating boredom using an empathetic conversational agent. I am Samiha Samrose from University of Rochester, presenting the work. This work was done during my internship with Affectiva. My wonderful co-authors are Kavya and Anbarasu from Sharon High School, who was also an intern there, and Ajjen Joshi and Taniya Mishra, both from Affectiva. So the motivation behind this work is we spend a lot of time in car to commute, and especially if we are having a long drive at night on the highway, it can get really, really boring. So driving alone is monotonous, which can lead to mind wandering, fatigue, distraction, and life risk, which means boredom as a negative emotion while driving can be very dangerous. So we can have the in-vehicle conversational agent that can intelligently detect the user's boredom and attempt to mitigate it by engaging them with the conversation. However, the traditional agent that we use right now, they don't have any empathetic engagement features. So in this work, we investigate whether conversational agent can help mitigate users' boredom. So to do that, we devised a protocol to elicit boredom among the participants. We explore whether the empathetic conversational agent can better resolve boredom in compared to a traditional non-empathetic one. To do that, we devised the linguistic structure of the agents and then validated the agents using a Wizard of Oz-based approach. So let's find out what makes the long drive boring. So when we are driving, we have to keep our hands on the steering wheel and our eyes on the street, which means we cannot seek any other stimuli. For example, we cannot watch a video or check our phones. And also, if the trip can be very long and we have to keep doing the same task over and over again. So to actually make the users bored in an actual driving time can be very dangerous. That's why we incorporated all these features into an in-lab task. And let's see what the task is. So it is an annotation task where the participant watches a first-person simulation video of a car being driven, and they have to annotate whether a road sign is appearing on the left side or right side of the street. They have to keep their hands on the keyboard and press Z or M to annotate left or right annotations. We have made sure that driving in the video is very slow and the environment is dark and there is not many stimuli to check. Every 3 minutes on the screen, a survey pops up asking what is the current boredom level of the user is. So in the 21-minute long video, the first 10 minutes happens without any agent. On the 10th minute marker, an agent initiates the conversation and tries to mitigate the boredom level. So let's look at the Wizard of Oz setup. So in the Wizard of Oz setup, in one room, the participant is performing the task in the screen. In the participant's laptop through the webcam, we record the participant's facial and body gestures. And also participant has a headphone and microphone to interact with the agent. In a separate room, there is an administrator of the Wizard of Oz. They also have a screen with all the dialogues of the agents pre-recorded. They can click and dialogue to play, and it will play the corresponding sound at the participant's end. So we designed two conversational agents. The empathetic agent, we named it Emma, and the non-empathetic agent, we termed it Nina. Because during an actual session, improvising can be difficult, that's why we generated all the dialogues beforehand and then recorded them using the same voice. So the only difference is the linguistic features. So what is the conversational topic during the task? We picked the 20 questions game, which is a very popular in-car game. The agent picks something and the user has to guess what the agent picked just by asking yes or no question. And I'll give you an example how the game is played. So I can say, I have an object in my mind. Can you guess what it is? You can ask, oh, what is the object larger than a football? And I can answer using an yes or no. A traditional agent will say yes or no. However, an empathetic agent can have more interesting responses. So let's look at what those responses or the dialogue properties look like and how we differentiated them. So from word level, you can see that from linguistic inquiry and word count categories show that our empathetic agent used more cognitive, social, and affective words in comparison with the non-empathetic one. In the sentence level, we also incorporated small talk, self-disclosure features. For example, it can say, I'm here if you need me for anything, which is kind of an assistant features. Even in dialogue level, we incorporated glue sentences to make a connection between the previous response and the next one. And it can also steer the conversation in an interesting manner. All these definitions and more examples can be found in our paper. So next, we will look at what the response would look like. And let's first listen to the non-empathetic agent's conversation.
Hi, I'm Nina. I will assist you today. I have a new feature to detect emotions and expressions. Would you like to enable it? Feature enabled.
So this is how the non-empathetic agent would introduce itself to the user. Let's look at how the sentences would be different for the empathetic agent.
Hi, I'm Emma. I am happy to be assisting you today. May I know your name? Nice to meet you. I'm capable of detecting emotions and expressions, but I'm not as good as you yet. We can communicate and work better with this feature. Would you like me to enable it? Great, we are all set. I hope you have a successful session.
So now we can clearly see the linguistic difference between those two agents. They have the same voice, but the linguistic structure is different. So now we describe how we designed the study. So we had 39 participants. There were 3 sessions. The first 2 sessions were 21 minutes long, and they were performed with either Emma or Nina, and we counterbalanced them. The third session happens with the agent that the participant chooses, and it's a short session with 6 minutes. In between every session, there is a survey, and at the end of the whole study, there is a semi-structured interview. So in each session, the first session, the agent introduces itself, like we heard before, and pretends to have a fake calibration. We did this to ensure that the participant thinks it's an automated agent and cannot doubt that it's a Wizard of Oz-based study. Then the task starts, and there is no agent during that time, first 10 minutes. Next half, the agent comes and the interaction continues. This is the overall flow of the study. So now let's look at the results that we have found. So first, we ensure and explore that the task was actually boring. So to do that, we used the NASA TLX index and showed that both tasks in the first and second session received really low score. Lower the score means that the task is less cognitively challenging, which means it's more boring. We've also made sure that the 2 tasks are comparable and very similar. So a pair t-test shows there is no difference between these 2 tasks. And also participants' self-reports confirms that they felt the tasks were boring. So next we see that, okay, so the agent is having a conversation with the user and we don't want to distract them because in an in-car scenario, it can be really dangerous. So to make sure what the participant's task performance level is, we analyzed those features. So to do that, we have the marker that when the road sign appears, we also have the timestamp related to that road sign marker. We also record when the participant annotated that road sign marker and with its timestamp. And based on that, we can calculate the accuracy of the task performance. And the results show that before the agent was introduced and after the agent interacts with the participant, the accuracies did not change that much. However, with the empathetic agent, even the recall improves better than the traditional one. So the next we explore what the agent's effect was on mood. So as I expressed before, every 3 minutes on the screen, it asks what the current boredom level of the user is. So it was a 21-minute video, which means there were total 6 prompts that were counted. So we place them on the x-axis. On the y-axis, we plot the boredom level that the participant reported. So it can be from 0 to 9, 0 meaning no boredom, and 9 meaning highly boring. So first we analyze before the agent came and after the agent came, is there any difference between those two boredom levels? So the purple line shows the boredom level during the traditional agent session. The green line shows the boredom level during the empathetic agent session. We found that during the non-empathetic or traditional agent session, before the agent came and after the agent came, there was no significant difference. The boredom level was kind of higher and stayed like that. However, for the empathetic agent, before the boredom level was really high, but once the empathetic agent started having the conversation, the boredom level went down and it was statistically significant. So next we want to see if this difference between these two empathetic and traditional agents' boredom level was different. And the comparison shows that, yes, so the empathetic agent reduced boredom in a range of 21 to 37% in comparison with the non-empathetic traditional agent. So finally, participants also evaluated what the performance of the agent is. And we are showing 3 of the 10 responses, survey responses here. Participants found that the empathetic agent was way more friendly, more empathetic, and the interaction was way satisfying in comparison with the traditional one. The rest of the survey responses can be found in our paper. So all this were self-reported data, but we also want to see how the facial expression actually changed for the participants. So as I mentioned before, we actually captured the participants' face and gesture through the webcam. We used those videos to extract those facial features by using Avdex. And for each feature, for example, joy, we averaged the scores across all participants. And we're showing one value here. For example, for joy, we saw that the joy feature was more for empathetic conversational agent. For example, the green line, you can see that there are different spikes at different points, way higher, which means the participant was smiling more, which refers to that we were having a more pleasurable experience. Also, for another feature can be for engagement. And we also saw the engagement feature was way higher for the empathetic agent green lines in comparison with the traditional one. So this is the pattern that we are seeing that, okay, so facial feature, as per facial feature, joy, engagement, and other feature attention were changing, but what was actually happening in the video? And we also explored that. And I'll give you a representation using one participant. So when the task starts, the person is doing the task and the person is not having any interaction because there is nothing to talk about. So they're not interacting at all. Then the agent comes and asks, like, I detected that you were bored. How is the task going? And the user starts speaking. So they have some interaction there. Then after that, there was some silence, but then the agent initiates the 20 questions. So at that moment, the person is playing the 20 questions. They were smiling more, having more small talks. So when the game ends, there is some silence. And after that, the participant might ask that, oh, can we play again? And then the engagement goes high again. Or the agent can also initiate by saying that, how is the task going right now? And there is some form of interaction on engagement there. And in the end, when the task begins, the interaction goes down again. This is one representation showing what was happening during the task and what moment the user was being engaged. So finally, what we see is empathetic conversational agent can successfully mitigate boredom in comparison with our traditional agents. Because the task is itself boring, it cannot fully remove the boredom experience. However, it can make the overall experience much more pleasurable and better. And in in-car, there is a way that the agents can be intelligent enough to detect and mitigate users' boredom without distracting them. And finally, we hope that the protocol that we proposed for boredom elicitation and the agent designed about the empathetic agent would be useful in affective computing and intelligent agent development communities. Thank you so much for your attention.